Welcome everyone, and thank you for attending today's webinar on what's new in the Parasoft C++ Test 2021.2 release. Your presenters for today will be Miroslav Zielinski.
Hello everybody, it's a great pleasure to be here.
Thank you, Mirek. And myself, Ricardo Camacho, Senior Technical Marketing Manager. So today we're going to share with you about a 30-minute presentation on our C++ test solution. So buckle in. On the agenda, we're going to cover new features and enhancements to our latest release of C++ Test, version 2021.2. We also have an educational simulated tour of C++ Test available through our website. So if you're new to our Parasoft and C++ Test, you can go ahead and take a quick glance and take a tour of this. Then Mirek will take you through a demo of our integration with Azure, and then we will finish it up with live Q&A. So we at Parasoft continue enhancing and expanding our strength in support of modern development CICD workflows, such as in agile software development using Microsoft Azure and GitLab. That is in this addition to existing integrations with Jenkins, Bamboo, TeamCity, and other build automation solutions like GitHub and more. So we now have Azure and GitLab extensions for the purpose of performing static analysis. Therefore, a C++ test dedicated Azure DevOps extension task is available in the Azure Marketplace. And this also includes the extension for the static analysis results interchange format, serif, which enables publishing static analysis results in Azure DevOps user interface. So that's really cool. Therefore, developers don't need to go outside of their working environment to view results. This will also expedite their now well-informed decisions about merging or not merging their code. Now, our new C++ test integration with GitLab mirrors that of the Azure integration. In fact, we have excellent online documentation where you will find dedicated GitLab pipeline examples in the C++ test documentation. Now, the reasons why we build these integrations is to bring high value to our customers by automating the testing they need to perform for these modern development ecosystems that they work in, and which our solutions reduce the labor, the effort, the cost in performing static analysis while also improving productivity and achieving compliance needs. Compliance with standards such as MISRA, AutoSART, or CERT. Continuing in this vein, today these workflows seem to include the VS Code editor more and more often. So development has continued enhancing our VS Code extension. In this new release, the ability to import static analysis results straight to the VS Code editor directly from Azure DevOps has been added. This is again a productivity or usability improvement because there's no need now to switch between VS Code and the browser to look at static analysis violations. Further expand our capabilities in the CICD workflow, we have added a collection of enhancements that further automate and simplify the complexity in obtaining structural code coverage. One of the most exciting additions is the automatic recovery feature if there is a hiccup or failure while integrating code coverage during the compile or build process. For example, if a compile error occurs, a problem log file is automatically created, which logs the actual cause of the problem. Code instrumentation is then halted from the file in question, and the file is compiled in its original form so that it does not break the build. So users can then continue testing and code coverage is captured for all other files. Later, they can look in the log file, determine the corrective action, which could include just a simple edit, or if it is something unexpected, they can report the problem back to Parasoft. Actually, the code instrumentation utility is now also able to collect all the required information and automatically generate the technical support package to be sent back to Parasoft, if it ever is needed. Now, what has also been enhanced and it's actually impressive, is a more CI/CD user-friendly code coverage report generation capability. Besides generating code coverage reports from within the build server, the code coverage artifacts like the code coverage log files, code structure data, and source code can be collected and used to produce the code coverage reports from any machine. The final HTML report generation is fully machine independent. So these enhancements eliminate code coverage build failures. It improves and strengthens the automation and stability of the CI/CD pipeline. And if there happens to be an instrumentation problem, teams are now able to quickly investigate and remediate the issue. The development team has also improved the Jama integration. The workflow between Jama, DTP, and CC++ test has been enhanced. Jama requirements can be imported into the CC++ test requirements view from recif files or directly from Parasoft DTP, which is where the bidirectional synchronization happens. As a result, users can browse Jama requirements and test specifications directly in CC++ test. They can also then analyze these requirement artifacts and create unit test cases that satisfy them without having to leave the IDE. Also, users can now filter the imported requirements, allowing them to expose traceability gaps between requirements, the test, and the tests that actually verify them. So this integration helps satisfy compliance needs and requirements traceability and improves productivity through its automation. And that very important synchronization and tackling of requirements in Jama and tracing with all those test cases that satisfy them. Now, we're always adopting new compilers because embedded ecosystems are always evolving. Our customers deploy new development solutions, so we need to keep in step and offer them seamless static analysis and unit testing using our solutions. Hence, we now support IAR ARM 9.2 compiler, GNU GCC 11, Clang 12 to better cater towards the newer x86 and 64 microarchitectures for Linux. Clang 6.16 for the ARM architecture. This is for Windows and Linux environments. And the TI ARM compiler 20.2 is now fully supported. And development has added support for Eclipse versions 2020.06 to 2021.06. So platform versions 4.16 to 4.20 to be more specific. Also, keep in mind, that we are always, again, keeping in step with industry coding standards. Parasoft continuously updates its coding analysis engine so that your development team is conforming to the latest coding guidelines and compliance standards such as MISRA, AUTOSAR, and CERT. In fact, we have added a new code analysis configuration for OWASP Top 10 2021. The static analysis enhancements provide more compliance accuracy, helping you deliver code that is safer, more secure, and reliable with less effort. Now, one of the things I wanted to show you real quick is this tour. If you come to our website, what's going to happen if you visit the CC++ product page, you can actually you'll see a button that says take a tour, simulated tour, and it'll bring you to this particular view, and you can start your tour of CC++ test. So if you're new and you want to learn about our product, kind of get a feel for it, this is CC++ test within the Eclipse environment. And as you go through this simulation, you can read about our product and get educated, and you can see here we can create or import a project. So as you continue, one of the things that we do is we give you the option here to take several journeys. One journey on compliance and certification, on MISRA compliance, also on static analysis, unit testing, and code coverage. If you want to share this with somebody in your team, there's at the bottom here, there's a tutorial. If you click on it, you can go ahead and click on share your tour, and that will copy this link so you can pass it around to your teammates. And you can always restart the tour at any point. As you start diving in through a journey, it'll start taking you through so you can read all the capabilities, features, and how it works. And there's also, if you miss something, you could always hit the back button and navigate through. All right, so one of the things I'm going to do now is pass it over to Nirik. He's going to give us the demo of the Azure, and then we'll come back at the end for a Q&A.
Thank you, Ricardo. You should be able to see my screen now.
Yes.
Okay, so let's see a quick demonstration of the C++ test static analysis integration with Azure DevOps. We're going to see how easy it is to create an Azure DevOps pipeline with C++ test static analysis, how to access static analysis results in Azure pipelines, and how to download static analysis results from Azure DevOps pipeline to Visual Studio Code for convenient remediation. For the demonstration, we will use an Azure account with a repository for the demo project, a Windows workstation with Visual Studio Code where some development will happen, and Azure self-hosted agent for executing build and test pipelines. For this purpose, we will use a Linux machine with Parasoft C++ test and GNU GCC compiler. During the demonstration, we'll define a new pipeline with C++ test static analysis and simulate a simple use scenario. A developer will pull the code, introduce changes using VS Code editor, and push the code back to the repository. The push operation will trigger the pipeline, which will launch C++ tests to perform static analysis. Static analysis results will be published and available in Azure DevOps for inspection, and also available for download to VS Code local instance for convenient remediation. So that's a plan for our demonstration. Now, let's see this in action. What you can see here is my Windows development machine. In the browser, I have my Azure DevOps account with an demonstration project. It's a simple C application which we'll be using during the demonstration. And let's say that our goal is to set up an automated pipeline which builds the code and runs static analysis on it, say, for example, to make sure that or to enforce MISRA compliance. For the pipeline execution, we'll need an Azure agent, and in my demonstration environment, I have it set up on the Linux virtual machine. Here you can see the agent is up and running, waiting for new jobs to process. So let's start with defining a new pipeline. I will switch to pipelines view now. As you can see, I don't have any pipelines defined yet, so let me create a new pipeline. We need to select where is our repository. It's hosted in Azure. We need to select the repository, and we get an empty YAML file, so we are ready to define our pipeline. And this is the first place where our new Azure DevOps integration comes handy, because if you open a Task Assistant and search for Parasoft, you will see a Run Parasoft C++ Test task that automates the configuration and execution of the static analysis. This task is available in the Visual Studio Marketplace, so to have it available in the Task Assistant, you will need to go first to the Marketplace and install it for your organization. As I mentioned, this task takes a lot of tedious work related to configuration and execution of the static analysis. Here in this configuration panel, you see a collection of entries where you can configure the static analysis. For example, you can change the compiler that is used for parsing the code. It defines the language dialect we are using for static analysis. And you can also check the selection of static analysis checkers that will be used for scanning your code. Let's say that we want to be MISRA C 2012 compliant. And once you're done with the configuration, you can simply hit Add, which will speed a snippet of the YAML file with the task configuration to configure and execute the static analysis. So you can use it for extending your pipelines. The task comes with an extensive documentation. So if you click here, we'll be taken to the Visual Studio Marketplace, where all the details related to our new integration are described. And this description contains several examples of complete pipelines that you can use as a foundation for your pipelines with static analysis. And here we have a pipeline example for CMake-based projects. And it so happens that our example project, our demonstration project, is based on CMake. So I'll make a copy, go back to my empty pipeline, and paste it. Okay. That's our new pipeline. Now I'm ready to save it. We'll stay with the default commit message. And we have our first pipeline defined. As you can see, the commit check-in operation immediately triggered the pipeline. So if we drill down, take a closer look, you can see that steps from the tasks from the pipeline are now executed, including the static analysis. It will take a couple of seconds to execute. So let's use this time and let's quickly review the exemplary pipeline we are executing now in background. As you can see, it is configured to be triggered for events on master or main branch. For execution, by default, it uses agents from self-hosted CPP test pool. Of course, this is something you can change, customize. And then we have two tasks that are responsible for building the code. This project is based on CMake. So in the first step, we are generating build scripts. Here, special CMake feature is used that generates compile commands.json file, which is used as an input for the static analysis. And here the actual build happens. Once our code is built, static analysis is executed. Static analysis uses compile commands.json file generated by CMake as an input. That's something that defines the scope of analysis. And then static analysis finishes with report generation. And here the report generation phase includes a new dedicated Azure Integration dedicated format, Serif format with static analysis results that is automatically published to Azure DevOps, and it enables static analysis results in Azure interface. So in the meantime, our pipeline has finished. So if we take a step back, here you can see we have a scans tab, and in this tab we have a static analysis results. Here we have a total number of violations, and below we see violations for each specific rule. So if we expand we see more details. We see snippets of source code with additional annotations that help in understanding the root cause of the problem. And at any time, you can click here on the link that will take you to the source code, to a specific place in the source code where you can see the problem in the context. And you can either take an immediate action here. You can edit the file and fix the problem, or if you are dealing with large batches of violations, it may be more convenient for you to look through them, analyze them in your IDE or code editor. And this is another place where our new Azure integration brings a lot of value, because it's now possible to download the results from Azure pipeline to the Visual Studio Code. So let's see an example of such a workflow. Let me bring up Visual Studio Code. As you can see in my local instance of Visual Studio Code, I have a C++ test extension installed. The latest release, as I mentioned, supports downloading results from Azure DevOps. And here I have a local clone of the repository with my demo project. So I'm ready now to download the static analysis violations that were generated in the pipeline. I don't need to run analysis locally. I can simply select load results from Azure DevOps. The extension connects to the to Azure DevOps. I simply need to select the reporting artifact, and as you can see now, all the 5 violations that we were looking at a few seconds ago in Azure DevOps are now downloaded to our VS Code, making it much simpler to deal with large batches of violations, because we don't need to switch between IDE and the browser. So let's say that we want to fix one of these problems. We can click here. Let's pick this one, for example. It says that tr local variable is checked for null after being dereferenced. Let's see here. In fact, yes, we have a test here, and 2 lines above we have two calls where tr variable is indeed the reference. So this is an easy fix. Let me do a quick edit. Okay. And we are done with this one. And let's say that another violation, this one, it says that malloc can potentially return null. Let's say that we are fine with this problem. We don't expect malloc to return null in our application, so we can accept this violation. So let's suppress it. Some message. And now we can select if we want to suppress it in file, in the source file with a comment, or if we want to use a separate text file that will be placed just next to the source code. I will use in-code suppressions. And as you can see, the problem is suppressed now. So I'm ready with my first iteration of fixing static analysis related problems. Let me commit my changes. Static analysis applied. Save all and commit. Okay, and we can sync our changes with the remote repository. All right, so we can go back to to Azure, and as you can see, our push operation triggered the pipeline, which is now in progress. We expect less violations now because we fixed one problem and one was suppressed. And as this is executing, let me now briefly discuss another integration we added in the latest release. We have a new GitLab integration. All the integration concepts are with GitLab platform are exactly the same as with Azure DevOps platform. So I'm not going to drag you through the very similar demonstration. Let me only turn your attention to official CPP test GitLab project available at GitLab. Here, very similar as in case with Azure, you can find documentation of the integration with GitLab. And here in the pipelines directory, you can find a couple of standard examples for the GitLab pipelines with C++ test static analysis. So if you want to add static analysis to your GitLab pipeline, you can take a peek here and steal some snippets of the YAML files. And once your pipeline is configured in GitLab with static analysis and executed, very similar as in case of Azure, you will get the results in the security and compliance vulnerability results, vulnerability report. This is the report I have opened right now. Here you can see the same set of violations we were playing with a second ago with Azure, and also if you click here, more details are shown. We are presented with this additional information that is useful for analyzing the problem. So that's about GitLab. Now let's go back to our pipeline in Azure. It has finished, so we can go back to VS Code. Let me remove our previous violations and let me download the latest results from the pipeline. And as you can see, we have 3 problems now. We had 5 initially, but we fixed one problem, and the other one was suppressed. And this concludes my demonstration. Let me quickly recap. We've just seen how easy it is to create a Azure DevOps pipeline with a static analysis. We've seen the value of having static analysis results integrated with the pipeline in the Azure DevOps interface. And we've also seen how helpful it is to be able to download these results to the VS Code editor and work on them using the IDE. These were very simple examples of the pipelines. Of course, in the real life, these pipelines are more complicated, but the integration is based on the same concepts. So that's it from me. Thank you very much. Hope it was informative. And passing back to you, Ricardo, now.
Yeah, thank you, Mirek. That was very informative, educational, and so seamless. It was just very, very nice. Now, before we go to Q&A, I'd like to highly recommend that you visit our website, parasoft.com. You're going to find lots of informative content and collateral. And also, if you want to learn more about C++, I've provided a couple of QR codes. The first one is if you want to try our products, to contact us. The second QR code will take you to the self-guided simulated journey that I kind of quickly demonstrated. Also, you can contact us through email, info@parasoft.com, or follow us on Twitter, YouTube, Facebook, and LinkedIn. Okay, so we're going to open it up for Q&A. We have a few questions. The first one I'll start with. Regarding Azure Integration, can I enable static analysis for my pull requests as well?
Okay, I will handle it. Yes. We were demonstrating very simple pipelines, but this works exactly the same way for the pull requests. If you have more complicated, more sophisticated workflows in Azure, for example, you do not allow direct commits to your integration branch to master or main branch only. You enable developers only to go through the pull requests. Static analysis can be a part of the pull request, and you can fail the pull request if there are any violations, or you can make them part of the review process.
There's a couple of questions I'm going to kind of merge them because they're similar. Do you support static analysis integration for Bitbucket, but also what about integrations with Jenkins and Visual Studio? So a couple of questions I'm kind of combining.
For Bitbucket, C++ tests, of course, can be integrated into Bitbucket. We don't have yet this level of integration, as you could see, with results directly available in the Bitbucket. This is on our radar. It's very likely we will be working on it very soon. For Jenkins, I believe this was the next one, we have a plugin which helps you, which shows you basically the results available in the Jenkins pipelines. And for Visual Studio, I understand this is about regular Visual Studio, not the Visual Studio Code. The functionality to download results from the Azure pipeline is not yet supported. Right now it is supported only for the Visual Studio Code.
Okay, great, thank you. The next question is, with the auto recovery mode for the code coverage, how do I know that there were some issues during the coverage build?
Okay, so this auto recovery mode is it is by default enabled, and if there are any problems, the tool will try to automatically recover, but it will leave a trace of these problems in the workspace, so you can simply run an automatic tool afterwards, and it will create a nice summary for you with all this information included. But you can also disable this auto recovery mode, and then if there are any problems with instrumenting your code, the tool will simply fail the build, which may be safer for safety critical applications.
So we have a question about the YAM. Will the YAM configuration plugin support custom compilers?
Okay. So this task for automating static analysis configuration and execution, it simply manages the command line invocation of C++ tests, taking out the burden of all these tedious manual activities, but it doesn't do anything for the custom compilers. So here the situation is still the same. You need to have a custom compiler configuration if you're working with an unsupported compiler prepared, and then you can use the task to execute it with this custom configuration.
Okay, great. Another question is, can I get the URL to the CPP test GitLab example instance?
Sure, we can share this probably in the communication after the webinar.
Okay. Yeah.
But
yeah,
you can simply search GitLab for Parasoft C++ test. This project is public.
Okay. Another question. Also, can I import violation results from DTP to my Microsoft Visual Studio instead of switching between DTP browser and Visual Studio?
Yes, there is a plugin to Visual Studio that allows importing results from DTP to Visual Studio.
And our last question that we have here, are you able to do this, to do any of this without Azure, such as if our environment was GitLab only? I think you actually talked about this, but...
Yes, so that's this integration looks really very, very similar. The YAML file for GitLab looks a little bit different, but all these all required examples to see how to set it up are provided in our official GitLab C++ test integration project, so you can check details there.
Well, that's all the questions we have. Mirek, thank you very much. That was very well presented. I enjoyed that. I always learned something from you. Anyways, and thank you, audience, for attending. Look at our website. We have additional webinars always available on demand or coming up. And thank you for attending. Bye-bye.
Thank you, Ricardo. Bye.